Okay, that does not make the lights work. I will just want to move the board lights. That's right there. Thank you. Coming back on again. Yeah. Right, so you guys interested in the dark and find the dark. We can't eliminate you and have these shown.
Yeah, that's what.
Computer science is not what it is. Okay. Normally the board lights are set to control. They were if they run on here, which they're supposed to be. Okay.
There it is.
I could break some of them.
Is that it?
Can people see and yet it's not blinding? That's a good compromise.
Yeah.
Okay. And we'll just put out lights as we need to. Come on in, become a programmer. Yes, someone can shoot me. I can shoot myself.
Oh, somebody.
That doesn't make it.
Alrighty, thanks everyone for coming. This is Dr. Andrew Withy. He teaches philosophy at the University of Auckland. He's going to talk about breaking out of academic coding. I'm sure he can talk a little bit more about himself as well.
Thank you all very much. Okay, so I am a philosopher, but don't worry, I'm not just a philosopher. So of course, philosophy studies everything except poetry, so that's okay. So I do teach philosophy, but I also teach computer science and logic. I teach computer science for the 50, and depending on what happens, I may also teach Comp Sci 389 this year or next year. So I do have a little bit of background there. And why? Because I have worked in software for about a dozen years here in Auckland and a little bit in Wellington. So I've been a programmer, I've been a consultant programmer, which means that I don't just work for a company, I work for a company, got another company, doing their stuff, solve their problems, and every few months, I'm in a completely new industry. Particularly, which means I run a bunch of programmers, and project manager, which means I run a bunch of programmers and their budget. So project manager is a bit of a political job as well. You've got to make the customer happy, particularly just needs to make the programmers work. I've worked in-house in companies like Scalability, Picture Building, and various travel companies. I've worked in small consultancies, large consultancies. So I've got a range of experience. I'm not saying that I'm a brilliant programmer. Some of these places I didn't do very well, but I learned stuff. And I got some really cool stories. Most of which I won't be able to share with you. This is being recorded. Okay. So I've done corporate finance, budget modeling, construction, worked for central and local government, never worked for corrections. Never. They're still back in the 1950s, the technologies in the 1970s, but their attitudes are terrible. Basic travel, I've worked for air travel, I've worked in ferry travel, I've worked in truck travel, all different companies, fast moving consumer goods. What does that mean? Retail. Television advertising, pharma research, online logistics, window design, spent a couple of years on the IT of building good aluminium windows. So I've got random coverage of stuff. And most of what I say apply to almost all of these industries and almost all of these things. So that can make it universal, but it makes it quite widely applicable. Notice you don't have Google, Microsoft, Amazon up on the list of people I work for. I sometimes worked with those people. I called trouble for them, but I was never technologically as able as the people from there. So if you are a technological elite, then you probably can get those jobs. I got shit done and buried the bodies, which is a different set of skills. Okay. So here's a question to get you guys started. If one developer, this is like one of those riddles, right? If three hens can lay 3 eggs in 3 days, but this is, if one developer can build a working prototype in 2 weeks, how long does it take a team of 6 developers, plus a project manager, design, tester, documenter, to build a production system? So 2 weeks of the prototype, how long for the real thing? You did 2 years? Cool, why?
I mean, it's a thing, it's a lot of people.
So with more people, things go slower?
Depends on how the team works. If the project manager is really great and organize everything, it'll be 2 weeks. Like bad.
So what kind of one developer that it might go faster?
It depends, but normally it should be the team will be long 2 weeks.
In a team, 3 weeks, okay, yep. Okay, yes, okay.
Honestly, like in my experience, the more people you have, the higher proportion of time is taken up by like meetings and stuff, and like just like getting people on the same track.
Yeah, the trick is that the extra person adds some productive time. If you lose 10% for all of the people working each person, you don't want to add more than 10 developers, because then you're losing more than you're gaining. And that's why a lot of teams sort of pop out at 5 or 6, and after that you need proper structures to work, or independent parallel working. Okay, so if one developer can build a working prototype in 2 weeks, hearing your stuff about teams, how long does it take one developer to build a production system? So what's the difference between a prototype and a production system? Who's worked on an actual production system, something that works in the real world? Maybe there's an internship job or project or something like that. Yep.
I guess the difference is that there's like more validation of like the behavior and testing, a lot more testing and design.
A lot more validation, testing, and design. I'm just repeating for the mic. Yes, and so does that make it 5 times as slow, 3 times as slow? What sort of figure would you have in mind? Between a prototype that works and does kind of everything vaguely to something that's actually productionizable?
So like 4 times?
4 times? Okay, cool. So I'm thinking probably for this team, it's probably 6 to 9 months to turn a 2-week, 1-person prototype going. And I'm assuming the team works. So those 10 people probably work 8 times as efficiently with 1 person. You lose a little bit of the team, but basically I'm saying 4 man years to turn a production system for a 2 to 3 week prototype. Okay. Now, why the hell is that? You're only really taught how to program prototypes in computer science. A little bit more in information systems, but not much. One of the differences between commercial programming and computer science or twiddling around at home is you don't need to have your ship work no matter what happens. You can just stop and change the code a bit. It's, oh, it doesn't deal with that, that's fine. Okay. So in real life, unless you've got a really cool job doing the research part in Google, which means you're 1 in 10,000 in computer programming, then you're not going to write any prototypes. I've written 3. And at least 2 of them were for political reasons, not my politics. But the bank was going to, basically we sold something to a bank, the bank was going to demand the money back and $2 million of damages unless we could build something that we tried to build for 2 months, it wasn't working. They said, you've got 24 hours to show it can be done. Build the whole system. We built a prototype in about 25 hours. And from a blank machine, they had a blank formatted machine with fresh windows on, put me in a room and said, right, it's 9 a.m. We're coming in at 10 a.m. with our senior management tomorrow. This is what we're trying to do over the last 2 months and next 4, make it go. And so from blank machine, I had to get a prototype working. It was a long 25 hours. And that's the sort of thing you can do in a prototype. You can do 6 months work, you can do reasonably 2 months work in a day prototyping. But then they said, okay, damn, we can't sue you. We're still not going to buy any of your services. We're not going to do anything more with you. We just know you haven't lied and deceived us. We just don't like your product. And that's all our prototype did. And that's about as much you can expect from a prototype. You either make a sale or you avoid a lawsuit. And that's all you've been taught how to do in computer science. Make sales or avoid lawsuits. So here's the difference. Here's a vehicle bridge. There's 2 vehicle bridges. One of them, you've got an axe or maybe a chainsaw you can build in an afternoon. Maybe you tie the logs together or nail them. Maybe you haven't, a whole bunch of paint. You can roll gently a couple of jeeps across. The other thing is a bridge. They both do the same job. One's a production bridge, one's a prototype bridge. It costs about $10 to $20 million per kilometer to build a 2-lane motorway. Why? You can do a bulldozer and create that in an afternoon. And this is what you're doing with the prototype. You're creating a bulldozer, clearing a bit of land, and you have a few bumps and it's all dirt and stuff, but you can drive where you want to go. And then building the highway costs millions of dollars per kilometer. And that's what you're doing with production stuff. Okay. So I'll think about all the extra stuff. I'll get back to that. I'll give you another little quiz to to go on now, you've got to feel into the differences. You've seen the picture, so now you understand it. But just bear a minute. So here's a real case that I got burnt on, which will also give you some of the answer. Okay, so you were trying to set up a travel booking system. This was House of Travel 2004, when airline things were just going online. In New Zealand was putting up a system, we were putting up a system. They had a 2-month start, we needed to catch up. So we got a list of database of departure and arrival locations and times for every flight in New Zealand, which is a port to a mainframe. There's 22 standard passes for booking, so you can book for fully refundable. There's 5 passes are fully refundable there from the expensive to cheap. They started with the expensive ones, with the cheap ones advertised, and they will have to get more and more expensive. And then with the semi-flexible and the unrefundable, and 5 passes of business class, only 2 passes of first class, because they're always expensive. So you've got these 22 different types, 22 different prices, and all these different routes in the cities with start and end times. If you want to fly from, say, Nelson to Tauranga, you say, well, I go Nelson to Hamilton to Tauranga, I go Nelson to Auckland to Tauranga, I go Nelson to Auckland to Tauranga. And you find the routes, you build up the fastest route, and you offer flights, offer prices. The prototype for this was built in 2 days from the data, nice and simple. And then they said, right, now we've got that working, you need to make an estimate. When I say an estimate, I mean a quote. When I say a quote, it means the actual budget to finish, and after that, your company uses money to write the commercial pricing engine for the domestic New Zealand flights. Oh, and before you finish that, you also need to make a quote for doing trans-Tasman and Southeast Asian flights. That's New Zealand to Vietnam, and then New Zealand to Europe. So we said, oh, well, we know these things are harder, so we're going to multiply by 20. We're going to say it's 40 man days to do the commercial pricing for New Zealand, even though we just got working the week before, because who knows what will happen. And we'll double that for Australia and Southeast Asia. And we'll double that for Europe. We passed this to our salespeople, and they said, well, hang on, that's 320 days. We can't charge them that. We just showed them that it works in 2 days. Let's call it 32 days. So it's basically poverty not there. So now you've got instead of 40 days, you've got 4 days for this, 8 days for this, 16 days for this. Probably math to get up, maybe it's 28 days total. Right, that's not a price we can sell to the customer. And then we built it, starting in June 2004. In June 2004, we finished the domestic market, same month. So that was good. So that seemed like it could be hard. We've got that going. You can't be too many more things for international travel. Passport is a separate issue. Just a couple more legs and a couple more rules for international travel. We got Australia, New Zealand to Australia and Southeast Asia working. Well, it went live at 3 a.m. on the 6th of December. I know that because the media was announcing it was going to go live at 7 a.m. on that Monday morning. We worked through the Sunday. We got to test at 3 a.m. They tested the release of the live at 6, and went live. The people with the big advertising campaign that booked 2 months in advance. Still wasn't working. So 6 months, we couldn't get the Australian Southeast Asia start working. When I left that company at the end of 2005, many of the flights from New Zealand to Europe could be booked with pretty reliable prices. So that's 18 months of work, and it mostly worked, apart from the edge cases, the difficult cases, the interesting cases, the profitable cases. So that was okay. We had about half a dozen flights each day, like bookings that we had to do manually. They were just the wrong price, and the make or lose another $1,000 just randomly out. And that was enough because we're getting thousands of flights a day being booked. So we just couldn't estimate, even with our experience, and even after we'd got New Zealand domestic prices sorted. It turns out flying to Australia, it's 20 times harder to pick up the prices. I don't know how much harder it is to go to Europe, but over 100. Sorry, getting echoes there. Completely unpredictable, even though I'd already worked for 2.5 years in a different travel flight company and done booking systems. Estimating tasks is hard, and that's something else you won't have any skills and you need to be able to be good at. Okay, so while you're thinking about that, here's some things that go in production code that probably haven't gone in computer science assignments. Logging. You log everything that's interesting, everything that's justifiable. Not for debugging, but so you can record what's happening. You have levels of logging. You have auditing, because some of the stuff will be controlled by legislation. If you're working in banking, certain things need to be logged and auditable and checkable, and you have to know who's done what when, and be able to sometimes roll back some of those things. Optimizing the critical elements, not writing your code so it's really cool and fast, people are readable, finding the 3 things that matter, so keep out the rest of the network, or in sales days, in slow, whatever. Best practice code reuse. So it's slower to write code you can use again, and it's slower to write code even if it's been used again than to write from scratch most of the time. But if you can reuse something and it takes twice as long as not reusing it, it's already been tested, it's already been proven for hundreds of days. You're copying and pasting, which takes twice as long as writing from scratch, something that you've already got most of the bugs out. It's best practice, it's worked. Any bug, hopefully another project will discover it, and then you can get that fix for free. It saves time long term, even if it takes longer to write using best practice code or reusing code from other projects. Error handlers, and not just error handlers, but when you're error handlers, right, what do? I was learning all this from first principles myself at one stage, and I wrote a piece of code that sent an email to me and to a log system, which was being controlled by email at the time, whenever an error happened. So 2 emails whenever something happened, our email sending broke. So if something went wrong, we sent 2 emails. Once caused 2 errors. We sent 4 emails. It sent 8 emails. And because it's quite fast, there's a lot of emails. I saw this phone in my inbox. I was sitting there live at 9 o'clock at night looking. So my inbox filled in. I tried to stop it. 5 minutes later, we got to the data center, pulled out the plug on the machine. An hour later, the CBD's network stopped overloading. So I just flooded the network completely on most of the CBD. Yay, error handling. We need error handling. We need error handling. Sorry, guys. The rest of you, that was 2001, so probably didn't affect your emails. You're okay. You probably are used to edge cases. So you say, well, I'm putting a positive number. Why don't you put 0 in? Is it a positive number? Is it not? Type in numbers. Why don't you type in a letter? If you design your code well, you don't have edge cases. So if you design it badly, if you design your code, you have handlers for edge cases. Like, if it's negative, what do I do? If it types something in, what do I do? If you design it well, you don't have edges. It's just a sphere, there's no edges, there's no things for it to go wrong. And that's hard. It's a skill, it depends exactly what you're doing, but you don't want to have edge cases where it's unclear what happens. You design it so that it just doesn't have any edges anywhere, or has secure of it. And that makes it a lot more stable. I guess you have radio buttons only rather than a type of text or something. Now there's nothing to go wrong. In that particular case, thinking about 4 cases. Contingencies. So this is going to call this, it's going to call this. I need to call a database server. If the database server is down, or the database server is rebooted, or swapping from one database server to the other because it's doing a hotspot on the disk. What does my code do? Because it needs to get a reply immediately. It can't wait for 5 seconds for the hot disk to start up, or for the failover to happen, or for someone to do a diagnosis to finish. How do I make sure all my code that works? Well, the network's being uncovered at the moment will be fine in 5 seconds. The something else weird is happening. My code needs to work in all those cases. We need to work in worst case scenarios. Actually, worst case scenarios is nuclear war or something like that. And moderately average scenarios. So what happens? Your credit card system is down, your error logging system is down, your disk is full on your backup hard drive array, and the emails you use for notification or text system is being flooded with something, possibly something you didn't do. What do you do? That's a reasonable number of things to go wrong at once. If you didn't handle any of them, you're fucked. If you handle 2 of them, you're probably still fucked, but you've got to be security. If you handle all 4 of them, you've got a working system, no one notices you get no credit. That's what you want. Okay, and you want maintainable, deployable configurations. This is still really echoey, I just won't stand there. That mic's turned off, who knows? Okay, so once you do these things, you make a change, it still works. You say, I need to deploy this to V7 server, I press a button, it deploys to 1, the coastal works to the other 6 servers, deploys to a 2nd, deploys to a 3rd, now it switches over to the code running a new system, the other one's an update. You want all of those maintainable, deployable things to be built into your code, because you're not going to be running for one user on one machine. And you can't just say, oh, it doesn't deal with that case, I'll just change the data manually. You need to have all of those things built in. If you're doing serious level production code, if you have Google in your title, I'm assuming that your customer base is 1 billion, or at least it's thousands. And if they're paying money and you fuck up, they're not paying you money anymore, and your employer might not be either. So yeah, you want scalability. One of the systems I did is for foodstuffs, but still use it, I think. They put a couple of $1 billion a year through because of their wholesale ordering. Foodstuffs, which does Pack and Save and New World, orders It used to order about $4 billion worth of stuff a year, it's up to 6 now. Most of that into our system was held together by me and 2 first-year programmers and sellotape and blue tack. And we didn't have a big enough number. We had like 2 billion, we had long, so we had 2 billion. We didn't know that people had 4 billion as a total in something. We didn't think it was scale up, that sort of thing. And so we didn't think that it was high, full speed in the first month. So not only was our hardware not scaling up, the size of our variables and the numbers weren't big enough. So we didn't really think billions was serious. We just popped through this here and hope. So that was like scalability of data fields, let alone what happens when you've got, you need to have 6 database servers in a row and 8 web servers, hot swapping, whatever. We never done any of that, how integers belong to. Portability. Does it work on an iPhone and Android? Or does it work under the different browsers? Does it work under Macs and PCs? Because if they say does it work, they mean all of those things. Not does it work on my computer once under one particular version of Chrome, but not the next version. Does it work on every single version of every product that's come out in the last 5 years in every browser? If someone's using Linux and is talking to someone using an Android phone, is talking to someone with an iPhone, do they get the same thing? Do the help files work the same for everyone? Is it portable? If you make an update to code, does it then propagate to everywhere? That's hard. Some of you can propagate it. That's hard. Graceful failover. So one of your servers burst on fire. I've had smoke come out of my servers. I've never seen flames. If that is possible. Or I've also put my feet up because I was lazy in the middle of the center and turned out my feet were resting on the switch. And a frame went down. They take half an hour to reboot. And generally simple with that. So when something like that happens, how does your code respond? It better keep working if it's public facing, or have a failover or redundancy or something. So you have multiple redundant systems. There are 3 major credit card systems in the world. You want just your code to preferably for one, the cheap one. I mean, that's not working because they have a 5-minute down window every 3 months. It calls the other one and it works and no one notices. And it sends to one and it shuts down what it has to reply. It knows to try the other one. You have redundancy because everything gets turned off. Now we're starting to see why the prototypes are easier than production. I mean, every one of these things I've got is from me fucking up somewhere. There's not too many more bullet points because I'm not putting them with the whole stories. Automated suite of test cases. You make a change, you say test 2,000 cases. All the things that I know they've gone wrong before, plus the new things, and it takes half an hour. You say, right, I don't mess up anything else. I didn't change anything else that broke while I was doing that. So you can't do all those changes manually. So you have automated split line test cases. You've got your development, your test environments, your user acceptance testing, probably your staging and your production, probably several different other layers of servers with different access. Each of them works slightly differently. The code needs to run through all of those in an automated fashion. You can't do manual installing different ones in different layers. It needs to all be automatic, but work differently. So your code needs to handle that. Often your dev will be 1 computer, the test might be 2. You might have a server farm of 50 for your live system. And some of them will connect to real credit card systems and some of them won't. And if you screw that up, as I have, then you're talking to the bank and your test case is taking money out of your credit card. Your credit card, because that's what you're using for testing. One of the reasons I got banned from flying in New Zealand for a year or 2 is because I bought an awful lot of airline tickets and canceled them all, like several hundreds for each of several days. That's the one I can say in the report. So these are the sorts of things that you want to worry about. Okay. And you want your code to be neutral, not your style of coding, because someone else is going to pick it up in 6 months or 2 years and play with it, and they can't rewrite it. Your code has to be readable for the next person, and writable for the next person, and you want someone else's code to be standard, because otherwise you're going to spend ages looking at it. And you want to write your business logic, because most of what you're writing is business logic, not the cool technical stuff. So when the business logic changes, which is every 3 months, you don't rewrite the structure of your code. Preferably configurable. If not, then the structure of your code has to be independent of your business logic. And that's still one I haven't worked out how to do, but I'm getting better. Oh, look, we've almost finished. Documentation. You want to actually have help files. Your help files need to be related to this version, not the previous version or the next version. Your help files go in your GitHub as well, link to your version and roll out with it. Professional wording, spelling, grammar, multilingual support. So your button does the right thing in the right language. You don't have smart comments or typos. That takes a huge amount of time actually getting rid of the typos done by developers. Training, communication, knowing when the business owns it, escalating people away, whatever you need in this process to run into their homes. That's all boring. If you don't have that right, you will sync politically, your project will fail if it works technically. production monitoring. Some poor sucker's going to sit there monitoring your servers, and you better be given the right sort of information. Otherwise, they'll poke at your code until they can see what's happening, and then it's broken. So you want to make sure you're providing the right monitoring information for the database, the DBAs, and other people who are looking at it. So in the middle of the night, they can see whether weird things are happening or not, know what weird is, and what to do about it, so they can help you performance tuning. Because at some point, you're going to hit a huge amount of data and you don't expect it. You're at a Skype day, Black Friday, whatever, and you won't have time to respond. And as your business processes change, your code has to as well. And finally, just need to work day to day, business as usual management. You need processes for that. So once you've done all of that, you've also got to do whatever made it work in the first place with your prototype. Okay, so that's the differences. And you probably haven't been taught how to do most of that in computer science, and most of that is boring. It's really boring, and without it, your code doesn't work, and you get yelled at a lot. So how do you get there? Well, maybe you learn that a little bit in business school if you do information systems. But mainly what we used to do, this is a few years ago now, we used to hire people. When I worked for Datacom, which used to be a respectable company, these days I've heard worse things about it, used to hire mainly honours or master students with ARA+, because it showed that while they didn't know anything, they could at least follow rules to get marks. Maybe they're smart, but they could do the things required to get an A+, it probably means they could do the things not be back throughout the years. They could follow instructions, or they were smart enough to get away with it. And that's what we wanted. The actual coding skills that you guys have learned, some of you are really cool, but most of that isn't that useful for the first couple of years, because we're teaching them a mindset and why the rest of the system is valuable. So we generally need to do this test, to put buttons on screens and to do data entry and testing, and to go like, oh, well, we've got this huge database, you need to enter people's names and addresses, create a screen for names and addresses, here's the sorts of formats you use, really boring stuff. If you can stick to that, deliver on schedule, make your code work, integrate with the rest of the team, and start learning how to code in a reliable fashion, all of which is boring and lots of people don't like, then we can start saying, here's a problem, solve it. Here's a feature for the customer, and so on. But if you can't program commercially, we can't let you near a customer, we can't let you make judgments, because your judgments are based on your prototyping. And then a customer says, how long? And you say 2 days. You go, fuck, that's 6 months. They've just told the customer 2 days, they're not going to accept more than a week now, no matter what we say. So you just cost the company 6 months of money. Or if it's an internal thing, you've just made a CEO, sorry, CIO or something like that, promises someone to be ready in 2 weeks, and it's not for 6 months. They lose space, they're angry at you, they're angry at the IT department. We can't have you making promises based on your skills until you've got skills, you think you've got skills. Some of you might, but once you think you're good coders, you'll be surrounded by good coders, particularly if you work for Google. You'll be at the bottom of the hierarchy initially, even if you're as good as anyone else, you don't have those layers of, I call them scars. You can call them experience if you want. Those lessons learned, those burn marks up and down your arms, mainly figurative. But I do have a couple of fingers that don't have feelings in the tips, because this starts to get really hot, and sometimes you get them out right now anyway. So yeah, sometimes you have actual scars. What else do we have? Teamwork, documentation, standard coding, accountability, hate it all. Turning up on time, dress for work. I dressed for work today. I'm wearing my Microsoft t-shirt. This is a Google thing. Maybe I should have worn Amazon, because Amazon's moving in, it was announced last week. But I wanted to wear something that was vaguely appropriate and slightly confrontational. I'm going to work for 8 hours. You turn up, you're paid to work 8 hours, that means you work 12, not 2. And if you're sitting there on your phone, you're not working, you're being a hazard and an inconvenience, and you're making people unfair. If you're sitting there on your phone, you probably should be let go. Unless it's the lunch break or something else. Sure, it's a work environment, not a play environment. But basically, you can use social media if you can do the last thing, which is you deliver deliverables. You make promises, you can meet the reasonable promises, you meet those promises. You don't screw anyone else over. And that's the first 6 months, learning how to deliver basic stuff. In the meantime, we just give you a whole bunch of brown stuff that you throw at the wall and see how well you go. So that's the bad news. I mean, some people give more structure to that. Google's got a really good development program, but most of the time as a programmer, you're out of your depth a lot of the time. I've lost track of time. Do you guys mind if I talk a little bit more? Okay. I mean, I still can't see the time. What is the time?
6:30.
6:31. I thought I was about putting down 31 that I thought. Okay. Okay, so being out of the depth. If you're out of your depth, you don't know what the problems are, you don't know how to fix, But if you aren't in that situation the first couple of years, then they don't trust you at all. They just give you the color and boxes and so on. You should be like this as soon as you can. That's the excitement. That's when you're actually doing programming. It gives you a problem and say, hey, this looks easy, I guess. It gives it to you. That means they work out the first approach. That may or may not work. Okay. So what do we do? If you're not doing the routine plumbing, you're doing the problem solving, so what you care about, you're going to be doing stuff you don't know what to do, and after half an hour say, well, how long is it going to take? And then a theory. And this is your promise, and this might, if you say 6 months, you've got 6 months to do it. Let's say a week, you've got a week to do it. And if you say 6 months and it takes you a week, you don't look like a hero, you look like an idiot. If you say a week and it takes you 6 months, well, you may not last for 6 months. At least there's more slack the first couple of times, but if you put the company's name on the line, not so good. So here's some ideas of why your task may not go on time. I'm assuming it will take longer than you think. So sometimes you don't understand the task. You have to deal with assignments, but everything is changing and still documented. The person who told you wasn't the person who did the task, but 3 removes away from the person who did the task who doesn't need the knowledge, and there's always things translated like a visa, but also lose information. You probably can't talk to people who know stuff initially. Maybe you're slower than your peers. It happens. Half the people are slower than average. Sometimes you can be really slow at one particular thing. You say, I'm not good at this thing, I'm good at these other things. You can't say that too often. But maybe you don't have the technology, even if you think you do. So again, when I was working in consulting, generally about half the projects I'd start and say, right, we're using this language. And I'd say, sure, I can learn that. And you can learn the language. Sometimes you could, sometimes you couldn't. Most of the time it's fine, but once it took me 2 months to learn something, everyone else learned for a week. I couldn't understand why I couldn't get it. Sometimes your code is just buggy, you're not stopping the code. Sometimes you get a code, just some bugs you can't track down, it's like weird. It's even unstable. It's 10 lines long and there's 50 bugs in it. That happens if you never only have 2 lines of code. Sometimes the task is generally better than you thought, like we saw with the flight issues. Or there's conceptual, algorithmic, or technology problems. Those are ones that our computer science training might actually help, particularly algorithmic problems. If you do philosophy or logical conceptual problems might also help. Customer team communication quality things. You're getting the wrong information at the wrong time, or you're getting the information a week after you need it, or worse, a week before you need it, and then they don't tell you that it's changed. These are all things that will screw you up. Let's see. Sometimes you need to wait for someone else to go. So it's only 2 weeks of work. You promised it in 2 weeks, but it takes 3 weeks for someone to get you the thing that you need to start. Now you've taken 5 weeks. You make it really clear at some point that you're still on time, even though you do it 3 weeks late. Sometimes the task keeps shifting. It's only 2 weeks, but it's a different 2 weeks of work every week. So you can never even do what's happening. It changes fast when you can code. Or it changes depending on who's judging you. Or you're doing something other than tasks because you don't realize it, or other tasks keep taking priority. All of those things feel the same initially often. I'm not doing things on time, what's going wrong? You need to identify. A lot of these aren't technological problems, right? It doesn't matter how good you are as a coder, a lot of the stuff just bites. You need to recognize some of that. Okay, so here's a quick rule of thumb. If another programmer of about the same seniority as you can do it, then it's you. You've not understood something, you've got a gap, something like that. People next to you are doing this problem you can't. Own up, hope to give another task that you can be better at. The senior programmer can do it and you can't. That's life. You expect people to have done this before, they have more tricks and more experience. That's cool, it's just a more difficult problem. I got taken off the flight pricing example earlier, and someone else was given a week to do it. It was 2 months, and they said, look, this is stupid, it can't take you that long. We'll put someone else in initially for 2 days, they asked for a whole week. At the end of the week, they came back, they were the senior programmer now for 18 and said, this is a really hard task. I'd like 6 months. And he knew he would never get more than a week in the project, so he'd go on something else. But basically he said, no, I can't do this, honey, that it is reasonably that difficult. So that helped. So if the programmer bounces up at the same point as you, but faster, they get stuck at the same points. Might take them an hour to reach that, but it took you a day to look up the same problems. Then it's a genuine problem. They're just faster at it, and that problem needs to be solved. That's cool. Might be someone else's problem, or technology, or design, or whatever. Then you get your VA or business analyst or architect involved, change your design, change your team. Sometimes the project gets split around the project plan, and that's all politics or money or dependencies or something else happening outside your control. And sometimes it's more of these or fewer of these or something else. Or sometimes you can prototype it in half an hour and you can never make a production safe. I had a project I went back to every so often for 4 years. And at the end of that 4 years, it's been live for almost 4 years. We put it live after 3 weeks. At the end of 4 years, it still wasn't really production ready. We just couldn't make it stable. It was working for 99% of the cases pretty quickly, and we could never get this last 1%. And that last 1% keeps shifting. And it's one of my few regrets. So identify, assess, communicate, escalate. Those are really important skills. Those are human skills. Those are teamwork skills. If you're coding alone and you only want to code alone, do not become a programmer. Or if you become a programmer, be a programmer in a company with 3 people in it, one of them is a coder. If you're working for Google, you're working in teams, you're working with all of these dynamics the whole time, you need to learn how to manage them. You need to have some either people skills or dealing with coder skills, which may be separate skills. But you need to have all of that stuff. Okay, I think that's all I wanted to say. So that's all really positive news. There are a few skills you've got a couple of gaps in, you fill them in, and that will really help you thrive in modern development environments. Okay, thank you. I just gave you answers to problems you didn't know you had. You're now ahead of the game. I mean, the game's not bigger and scarier and different than what you thought, but isn't that good news? Or not? Okay. I guess I should take some questions, and they can be on this, or they can be on how philosophy affects computer science, or tell me your worst war story, or where's the pizza, whatever. If people have questions or worries or think this is rubbish.
How did you get into philosophy from computer science?
Okay. After my second burnout in the industry, and you can burn out in the industry, the 8 to 12 hours I was talking about, I did work full team for an average of 15 hours, 6 days a week for 9 days. And they were averaging 15 hours on my team, so I did every hour of E1 work was 18 hours a day for 7 days for 6 months. After the second time I did something that stupid, I kind of burned out, and I couldn't program around a paper bag for 6 months. And they basically said, well, we're now getting used to put the buttons on the screen and the coloring in, so you can't do what you used to do. And I thought, stuff that, I'll go off and do a history paper. And it turns out I'm not good at history, like many other things. So I did a couple of other things, but I ended up saying, I'm going to finish my BA, and I sort of started a few papers off. And then I said, oh, I can do logical. That sounds fun. It's like computer science. I've got this other writing stuff that I've just got a couple of papers in. I'll do my honours in that. It's a whole lot easier than working. I mean, at one stage I was doing 5 papers and working, and that was easier than working full time because I could stop at 5 o'clock. I could think about something else. And then I thought, this honours is really easy. I'm doing 4 postgrad disciplines. It's working. It's restful and interesting. And you get to write proofs. And then they get to work like 30% of the time. And that's 29% more than my code. And then after that, I thought, logic's actually quite hard. Philosophy can't be that hard. So I did a master's in it. And I did a PhD in it. And I said, right, that's up. I burned out again. I'll become a maths teacher. Ended up being a maths teacher. Turns out I've got a PhD in philosophy. They say, you're a bit weird. And then the philosophy was hiring. So I stuck in here part-time and stayed too long, and now I'm permanent. They can't get rid of me. So that's how you become a philosopher. If you want to plan a career, you can't anymore. Plan careers sort of without the window lessons that will serve us somewhere back in, I guess, in the course of 86. Sorry, you had a question. Yep. I did my teacher's training in Western College. I wasn't really good. But yeah, maths.
Yeah.
Yeah. Oh.
It's 2014.
Sorry, you what it is? Hazel. Vaguely. You would, a young lady, people are saying, fuck, when you put a hand up, that was the only way to communicate. This is when I really don't need my problem from you now. Yeah, you still, yeah, she was trying to learn how to do stuff and ask questions. She didn't put a hand up, she still had to say, hey, fuck you, to get attention. But that's the one I remember. But yeah.
Very
Yes. Yes, the hockey guy.
Yes.
Yes. Yeah. I probably have a list of your name on it in comments when I'm both doing grades and stuff. So I can look you up and I can just give advice to next employee and say something you can I math. But I wasn't a very good math teacher, maybe not during training. But yeah. 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 So yeah. Okay. So there you go. Part of my story being confirmed, so it's all true.
How did you enter the comp sci you became a philosopher?
Well, traditionally, I mean, computer science was invented by a philosopher, logician, but a philosopher. And they invented it because they're trying to solve problems in maths. The mathematicians don't like about just doing maths, not look at the holes in maths are. Philosophers get around poking holes in stuff. We said mathematicians don't know what proofs are, or design what proofs are. Hey, let's automate this, it's boring. And then when I say we, I guess I mean Turing, you know, he was a philosopher. Good, right, well, I can now beat the Nazis using this stuff, it's useful. And then IBM said we can make money out of it. And then it goes forward. So computer science, people get philosophy to teach from the theoretical computer science stuff. They always have, well, since 1982, I think. And so when the guy who used to retired, I was the next man up. But actually, they looked at all the logicians and said, that's the most malleable, which I think is a terrible way of choosing someone, and a really bad judgment of me. But yeah, so I got to do computer science 350. And I did pass it back in the day too, so that was good. But they don't really teach you this stuff in computer science, because it currently scares students off. I mean, I haven't talked to any practical skills for this, just the names of practical skills. But they say, you know, lots of people roll into computer science, they don't like computer science, they want to get the money of being a programmer. And that's fine if you're okay at coding and you're good at all of this, but you're great at coding and lousy at some of this, people will manage around you. If you're only an average programmer, you need a lot of the skills to be able to survive. And we don't teach that. So basically, well, the good students will be fine, we don't really care about the rest of them, have got their money. And that's silly, you've got to get more money for training them on this as well. And then send you all out into the workforce. No. Just university is not here to teach you life skills. Yes.
What do you do to get away from all of this and kind of relax and renew?
I mean, when I was in the industry,
Yes.
well, I did have 4 hours of sleep a night. And I used to drive back from the force to home. And if you eat, you can't program as fast, you can stuff falls on your keyboard. So those are my most of my relaxation. I did say I burned out a few times, right? Yeah. When I did burned out, and I lost sense of language. I lost at one stage, I lost the ability to do more than walk. My brain wasn't working, I couldn't run. I got fucked over a few times. People do more stuff like their families, their hobbies, their friends, which is an important word I need to learn more about. So yeah, you should be able to do a life balance thing. Google doesn't like this, they want you to stay at work 6 times 12 or 7 times 14 or whatever. But if you get a job where it's 5 by 8 or 5 by 9 with the occasional crisis, and make sure you've got a healthy life outside, or at least an active life outside, mixed with friends other people, and that doesn't get on top of you. If they push too hard, you need to say, this is my career for the next 5 years, buckle down, do the damage to my personality to become successful, but get out after 5 years on the path to human. Or you say, well, Google's asking too much, and I'll just have to turn them down, that this environment isn't for me. Or you can be like me, and no, I'm not. I mean, you might want to be here in a while, you do not want to have a look at the brain damage that are caused to myself as well as the social form. Yeah, I said I've rebuilt how I speak, how I walk and so on, so I've lost those people now.
Like, what's the question like? How did you get that back? That's
Oh, that's just like I couldn't say no. I mean, I wanted to get things on the deadline, so I work my people harder, and you can't have your people working harder than you. So I had an shift, and who was there for every shift? We made sure everything ran. You take responsibility. If you don't take responsibility when you're running a team, then you're a lousy backup of a manager. But if you work your own team and you put yourself first, you win. Okay, so I didn't quite get that right either, but I was less evil by flogging myself harder than I flogged everyone else. I say less evil because 2 suicidal teams by my staff on my watch, probably that I caused the environment for. That's unacceptable. 1 is unacceptable, I don't know what 2 is. So that's not uncommon in the environment. If you are obsessive, like some of you might be, and you enforce your obsession on other people, or you're a manager who's obsessed and enforces it on you, you have to look after yourself. And people will come in and not know what the standards are, and you'll be coming in and not know what the standards are. And you'll be trying to live how everyone else does. And if you only try to imitate people who have no life with balance, your mental health will get risk such that you think, I'm a failure, it's leaving me not to live. I have fucked other people up, not just myself. Right? I mean, I could say, yay, no successful suicide attempts, I win, but that's not a good way to keep score. I was a lousy manager of some of this stuff. I'm a whole lot better now, but I still wouldn't work for me. And so you've got to look after yourself, because I'm not the only person out there. So I don't know whether people thought it was going that way, but next question.
If you don't enjoy that stuff, what are the reasons to stop you from dropping out?
Ego. If you don't enjoy it, but you keep on doing it, it's egos. Your ideas being part of the program might pay all of this what as the program is. But I think of myself as a programmer, I wouldn't know what else I would do. I like the idea of being a programmer because I don't actually like what this is, or I like the money, or my girlfriend, boyfriend, cat will leave me there, or my parents will be disappointed. All those external pressures. This is just the peer pressure bullying stuff from high school. So find yourself doing a career that you either don't love or aren't good at. There's lots of people who say, I want to be a programmer, I will be a programmer, and that's just not very good. And they probably shouldn't be there. It's not good for them, and it's not good for the company, and I'll never get anywhere and I'll get frustrated. Give yourself some time. If it's not for you, with your mental health, with your capability, move to something else. There's lots of room in philosophy. Like we hire in New Zealand 1 to 2 philosophers a year. For most people in North America. So it's a pretty easy job to get. But yeah, computer science development is an easy job to get into. It's hard to stay in the right environments. There's lots of companies looking after you, but the ones who hire out of graduates, the ones who churn from graduates and need replacements. Why do you churn through graduates? It's not to promote them all up to successful careers, it's because you use them up and you step them out. So the ones that it's easiest to get a job with are the ones who are most likely to be environments that aren't safe for you. And how much you are prepared to suffer. I don't think you might suffer as a work a couple of late nights. It doesn't do damage to the cycle of who you are, to stay in that job, and how much you think, well, I've tried 3 months of this, I'm going to swap to a different company where they actually care about human beings.
Is there actually a vision for sustainable?
There's a huge lot of training graduates for cheap and disposable every year. It's like saying the slave labor really a good economic model. You think, well, no, we'll get around and there'll be escapes like the enforcement will allow people to oversee the whips, and the whip costs alone in the chain, but it's still economic. Yes, they treat you like crap, they have cheap managers, and they get to say to the customer when they're taking too much money not delivered, we fire the person responsible. They come grade and you one. It's also you don't need to have good managers with good people skills. Everything's cheaper and nastier, and you can bully all those natural things people shouldn't do in places and do, all we put in there, that's so much cheaper. But it's highly sustainable unless we say no. And by the way, I said no right out. But there are good places to work as well. You just need to not say this is what IT has to be. I'm just not good enough. You say these people are assholes, they're using us as utilities, as resources. It's only 3 months into my career, but I can do something better elsewhere. If I can't find a job elsewhere in IT, I'll be a barista when I look, and I will still be staying unbroken. Or you can say, I'll tough it out, and after a year, I'll find another heat, and I'll impose my will on other people. Which is frankly far too much fun. Being able to hurt other people and say it's professional, it's a shitload of fun for those people who don't have great personalities. I had a lot of satisfaction out of doing very bad things. And if you have managers like that again, not good. You recognize these people, I don't want to say psychopathic or sociopathic for technical definitions, but yeah, a lot of people, I mean, computers aren't people don't have great social skills. If you don't have that and you like power other people, that's worse. A lot of people in management, and we're still salespeople often do the management. You've got sales and marketing managing IT teams, that's generally going to fuck you over pretty quick. So they care about your bonuses, which is your sales and not your delivery. Again, things to watch out for in companies. Lots of good companies, lots and lots of bad companies. Look after yourselves. Recognize some of those signs as probably not you. I mean, for 5% of you, it'll be you. But maybe not in this group. You know, there are some bad programs, people who just don't fit. But a lot of the time, it's the company sort of no question. Yeah. Yes.
Are you able to like name some features you might see in like adverts and interviews, things to look out for to avoid a company like this? Obviously, hunting job hunting.
So ask the person who's interviewing you whether you can contact some of the staff working in your area and have a quiet chat with them. Not whether there can be a supervised meeting with your manager, but whether you can just have a quiet chat with a couple of them with a coffee, and then say what's it really like. That's the first thing. Secondly, most of the managers are salespeople or marketing people. You don't need to have a programmer running programs, but you want someone with some technical experience rather than being driven by KPIs and our program. So you look at the sort of hierarchy, look at the turnover, ask the human resources person who got the employment, so that the agent that you work with, they probably set up the job, how often they're hiring, what their turnover is. If they have a lot of turnover, that's a bad sign. It's a reasonable thing to ask. And if they won't tell you, maybe there's protecting their privacy, but maybe they're just hiding a customer. So a really good customer for them, because they have lots of hiring and a really bad place for you to work. So be aware of some of that. Talk to other people in the field, and often, if it's lots of the banks have reputations, different reputations, different banks. Any big place like that does start with a different reputation than I work for it now. As of 2011 to 15, I wouldn't have worked without it. I don't have its latest reputation. But I definitely would have worked for May 2000. That wasn't a mistake. The company's changed. And reputations are known by other people in the field. So that's a partial answer. But yeah, talking to other people who work in that department or a department next to it, who you wanted to work with. You don't have a manager around, you say, what's it like? How long are the hours? How often do they, what's the responsibility change? Let your manager step in front of people and say, no, my team, my fault, I take responsibility. Or they say, that's the one that programmed. If you can step in front of this charging train, if you've got a manager who's sitting in front of the charging train, you stop up and then turn around and yell at you, it's a whole lot better than the train straight through you. You want people who will protect you and sit down. That's one of the few things I did successfully. I always confront someone, and it's useful when I'm confronting someone to protect my team. If you don't have a manager who's got your back, that's going to suck, even in an internal company. And you can't ask the manager, do you have my back in an interview? Because your answer will be yes. Of course, my team loves me, I will always protect you, that's what I do. So, yeah.
So you mentioned high turnover or low turnover.
Yeah.
What is the turnover like in various industries? What do you consider very good or very bad?
As an early graduate, you possibly want up to 3 jobs in your first 5 years. This isn't answering your question, it's asking like answering a later question. But after that, you would have longer career thing. So if you're getting still every year you're changing jobs up to 20 years, that's probably a problem. Either that can be bored very quickly or you've been bridges. So if they've got a high turnover of just graduate students, because graduate students move on after 18 months, that's normal, that's fine. But a high turnover of middle to senior positions as well, that's problematic. And so it's the type of position that you're changing. So if you're architects, your designers, your PAs are all changing over. Everyone up to but below the management layer, bar tuning class is a problem. If they're feeding a lot of graduates, often going up, so they need to replace this, some going out, that's fine. So I can't say if more than 30% turnover a year is bad, but more than 30% turnover of senior technical people is bad. You want your long-term architects and stuff to be long-term, 5 to 10 years. But your grad students might average 2 or 3 years. Some of them will stick, some of them will move on after a year or so. So it's more complex. And they're not going to give you that. You just ask the people, hey, there's a lot of turnover in your company, and they'll probably say yes or no. And they'll do it relative to what they know. IT is a cool place to work, don't get me wrong. There's just, there are traps, and they don't teach you the traps, and the traps will break people around you occasionally.
With regards to Datacom, can you say what specifically, or why do you see the reputation to be lower?
Sure. So Greg Davies became CEO in 2004, and over that time, late 2004, mid 2005, and he changed the model from we provide solutions to we provide bodies. So you say, right, you need coders, here are a couple of coders, go out on the site and I'll do what you want. What is your problem? We'll help you with what your real problem is, we'll provide a solution. We're going to try to solve problems or do that. We say, we're a body shop. We now consult by giving you people to fill in your shorter program, your broken team, have some of ours. They'll be reasonably well trained, they'll work in your company and do things your way. And that's what Datacom was, which is a whole bunch of skilled people working in teams and so on, and became some sort of hiring company. So you could just like renting labor. So it lost a lot of the core skills and the development and progress inside that. Usually now in 6 months, no one knew what you were doing, you came back to solve you somewhere else. It was a more efficient short-term model, and it fucked over Datacom, and he's the bastard who tried to get you fired anyway.
I think let's go outside. Pieces there, so
yeah. Sorry, Greg. I also liked you with PM for quite a while too. I didn't need to get liveless. I slipped. I didn't mention Rob Pipe at all, so I was good.
No, so you can talk about it over pizza.
Yeah. Cool.
And recordings like this.
Yeah.
Thanks so much too.
Yep.